Alright, you guys, so this is going to be your first video lesson tutorial from Mr. Hudeberg. Alright, and we're going to focus primarily to begin with on data and units. Now, so before we delve into atoms and molecules and reactions and all the really cool stuff in chemistry, we're going to do some other really cool stuff, primarily dealing with units. Alright, because they are paramount, absolutely utmost importance in science, and we'll talk about units quite a bit. Now, one thing we're going to do first, though, is just do some quick terminology, differentiate between qualitative and quantitative. I'm not going to spend much time on this. Quick run through. Ready? All right. So when we talk about qualitative data, we're talking about qualities of something, right? Substance reaction. Now, it's still real scientific information. It doesn't always have to be measurements and numbers. It can be some other sort of descriptor. So, for example, ponderosa pines, fairly common tree in the Wall Wall Valley, right? Their bark emits an organic chemical that has a faint vanilla scent. Now, that is scientific information about ponderosa pines, but notice it is not a number, right? There's no units attached to it. There is no number attached to it. It's just providing some information about a quality, all right? So I'm going to erase that just so I can see the rest of the screen here as we go. At room temperature, water has a relatively low viscosity. So there's my information about water, right? But that information has no number, no units attached to it. Now, when we talk about quantitative data, we are actually talking about precise numerical information about a substance or reaction. So in that case, so if we were to say the freezing point of pure water is 273 Kelvin or 0 degrees Celsius. Now notice two things here. We have a number describing it and a unit. A number and a unit. Those are just two different ways of describing temperature, by the way. All right? So qualitative gives us scientific information. It's not a direct measurement with a unit. Quantitative is scientific information with a direct measurement or unit. All right? And as simple as that. So moving on here. Let's go units specifically. All right? So what we have to understand about units is we can have numbers and measurements, but those numbers and measurements are meaningless without units. So they give numbers meaning, right? So if I ask you a question, you tell me two what? 2 apples, 2 bananas, 2 meters. You have to have units attached, right? They are just as important as the number when doing calculations. In fact, I would say they're more important, but we'll give them the equal value for what we're doing right now, right? Understanding units and conversions help you to solve problems, all right? So, in math class, they show you all kinds of algebra tools and so on. Those algebra tools actually really make sense when you start attaching units to your numbers. And this is all going to come to you guys. I'm just uploading this information. But units. So important. All right. Now, when we talk about units, what kind of units are we speaking of? In this case of chemistry, we're usually, not always, usually going to use what we call SI units. Those are standard units, and we use these types of units so we can communicate with anybody, any country, anywhere in Africa, Nigeria, whatever. They're going to use probably the same units we do if we're talking chemistry language at least. All right. Now, no need to memorize this. Now, another important bit is our unit prefixes. Now, this is a table right here, right, that has prefixes and what they mean. Now, tera, giga, mega, right? You guys have, whoa, backtrack. Sorry, relatively new technology. Occasionally, I get a little screwed up there. Tera, giga, mega. Those are when we're talking about really, really big numbers. So when we're talking computers that have a huge memory, etc., we use those types of units. Now, for most of our measurements, like in the chemistry lab, we're not dealing with those kind of units. We're typically going to be going with our base unit. So let's say we're checking the mass of a chemical we're going to add, right? Our base unit in that case would be grams, right? So we're not usually going to use thousands of grams of something in the chemistry lab. In fact, we'll often be down here in the centigram. So 1/100th of a gram. Those little balances we've got over in the lab room, they measure down to the nearest 1/100th of a gram. All right, so we're going to use these prefixes a lot, right? And you guys are going to get your own copy of this, and it'll be on some other slides as we get to it. All right, so these are big, and these are small. And it just depends on what type of units we're looking at. All right, so dimensional analysis. This is referring to the process by which we convert from one unit prefix to another, and sometimes even one type of unit to another. But here's two basic rules for now, and we'll get more complex in this as we go. But for now, two basic rules. Rule number one, we're moving to a larger unit prefix. So we're going from a small unit to a larger prefix, right? You're going to divide. And when I say divide in this class, the way we express that is if it's a fraction, it's going to be on the bottom of that fraction. And I'll show you what I mean by that exactly, right? So we're going to find our difference in magnitude. We're going to divide by that, so that means that magnitude, difference in magnitude, is going to go on the bottom of a fraction, right? So just like if I had 1 divided by 4, I can write that as 1 over 4, right? 1 divided by 4, 1 over 4, or divided by 4 goes on the bottom of that fraction. That's what I mean when I say that, okay? So going to a larger unit prefix, we're going to divide, which means we're going to put our difference in magnitude on the bottom of a fraction, and this I will show you how to find shortly. All right, next thing to know here, and again I'm going to do some erasing. So if I am going to a large unit, I divide. It makes sense. If I'm going to a smaller unit prefix, I multiply. And if when we divide, we put it on the top of a fraction. When we multiply, what do you think we do? Top of fraction, right? So if I wanted to multiply something by 4, so let's say I had two apples, right? And I want to multiply that by 4, I would put that as like 4 over 1. Now, why do I put the over 1 when it's the same number anyways? You'll see, because we're going to start talking about units and how they cancel here in 1 minute. So that's what I mean when I say top of fraction, my factor of difference on top of that fraction. All right, so let's put this into practice right here. Here's a real problem, like what you might see on a test or quiz. Calculate the number of centimeters in 2.45 kilometers, right? So what's important here first, before I look at this table over here with all my prefixes and so on, I'm just going to write this in a different way, right? So what's my starting quantity? 2.45 kilometers. So I've got 2.45 kilometers equals blank centimeters, right? So I'm converting from kilo to centi. Those are my prefixes right there, kilo, centi. And I apologize for my writing, but deal with it. All right, so next thing I have to decide then is what are my magnitudes for those. So kilo, I find my k here, it's 10 to the third. So I'm going to write a little 10 to the third power up there. Centi, the little c, down here, 10 to the negative 2 is my magnitude. All right, so remember when I said if we're going from a large to a small, I used that difference in magnitude language. This is what I'm talking about. What's the difference between 10 to the third and 10 to the negative 2, right? So essentially, if I had a number or a decimal line or whatever, how many spaces would I have to go from 10 to the third, 10 to the negative 2? It's pretty simple. Difference between 3 and a negative 2 is 5, right? So my difference in magnitude is 1 times 10 to the 5th, right? So that's my difference in magnitude, right? Once I know my difference in magnitude, then what's my rule? Am I going from big to small or small to big? In this case, I'm going big to small because 3 is a much bigger number than negative 2, right? So my rule is I multiply when I do that, which means it's going to go on top of that fraction. So here's how I'm going to write the actual problem out now. My starting quantity is 2.45 kilometers, right? And I'm going to multiply that by, okay, my difference in magnitude. So it's going to go on top. So 1 times 10 to the 5th cm over 1 kilometers. Like I said before, why you put that 1 on the bottom? Because you need to show that you're converting from kilometers to centimeters, right? And we can even picture this as an over 1 if you want. right? And what happens when I do this? I get to cancel a unit. I don't know if you guys have done that in math yet, but if you've got the same unit on the top and the bottom of a fraction, you now get to cancel that out, right? And so in my calculator then, right, I would go 2.45 times 1 times 10 to the 5th. Now, if you don't know how to do scientific notation on your calculator, you need to talk to me tomorrow. Get your calculator, bring it over to me, and I'll show you how to do that. We will talk more about scientific notation in a little bit anyways, but for the sake of what we're doing right now, I want you to be able to do that on your calculator, all right? And we would find when we multiply that, we'd get 24,500, or in scientific notation, which is a perfectly acceptable way to leave it, 2.45 times 10 to the 5th centimeters. Now notice in my answer, I'm also putting my units. Always do that. All right. Next problem set then says, let me do some erasing here. To calculate the number of kiloliters in 2,345 milliliters. Now I'm going to do something real quick so that we can see. Go here. Backspace. I want us to be able to see that problem. Sorry about that. So there we go. I'm going to go back to my slideshow from current slide. Here we go. Back in business. Again, apologize about that. So, calculate the number of kiloliters in 2,345 milliliters. So again, I'm just going to write up off the top. I'm going to write this slightly different. I've got 2,345 milliliters equals blank kiloliters, right? And I'm going to write down my magnitudes. So milli, I found it down here, that lowercase m, 10 to the negative 3. Kilo, I already did this one in the last problem, 10 to the 3rd. All right? Now, that is a difference in magnitude. So from 10 to the negative 3 to a positive 3, diff in magnitude is 10 to the 6th, right? Or 1 times 10 to the 6th if I'm using scientific notation. All right? Now, I'm going from small to big, so the rule number that we saw earlier is from small to big. That means I divide, which means this number is going to go on the bottom of a fraction. All right? So let's write that out. So I'm going to go 2, 3, 4, 5 milliliters over 1 times 1 kiloliter over 1 times 10 to the 6th milliliters, right? So again, notice I'm putting my units in the setup for my problem because I need to show Mr. Huderberg that I'm canceling milliliters, converting to kiloliters. I knew that the 1 times 10 to the 6th had to go on the bottom of that fraction because I'm going from small to big, which means I divide, which means the difference in magnitude goes on the bottom of that fraction, right? So now I would show my answer in kiloliters when I multiply, so or actually divide in this case, right? So 2,345 times 1, 2,345 divided by 1 times 10 to the 6th, right? And again, I hope you guys know how to do that on your calculator, but I'll show you how. If you don't, when you do that on your calculator, you would get 0.00234 kiloliters, or if you want to do it in scientific notation, 2.345 times 10 to the negative 3 kiloliters. All right. Now, for now, this is going to be the end of it. So what I'd like you guys to do in class tomorrow, right, is we're going to do the first 2 sections of Chem Quest 2, right? The subsequent questions to go along with that are 1 through 7. We will read and annotate the information sections. We'll do that together tomorrow, right? We're going to work with our group members to work our way through those problems. And then if you have time in class or not, there's a little quiz on blend space that you'll take just to kind of see how we're doing. Likewise, if you guys are super excited and you want to get started on that ChemQuest 2, you can go to blend space right now. Find that little ChemQuest 2. You can download it and print it and get started if you want. Although if you're all done, don't think you get a day off tomorrow. I'm just going to make you help out your group members. All right? Until then, keep your ear to the grindstone.